Hello! Okay, we are going to try doing the unrestrained passenger lab at home. It's totally doable. It can happen. If you find this, you can print this off on Google Classroom, or if you want to just read it from there as you're going, that's totally fine too. And then use some paper to write down your data for when it's time. So we'll just go through some introduction stuff, okay? Velocity is speed with direction, okay? It's a measure of how fast something is going. We know this. It always includes a direction, which means it is a vector quantity. For example, if you're driving to the cabin in your car, you may be traveling at 100 kilometers per hour. This is your speed. However, if you're traveling at 110 kilometers or 100 kilometers per hour east on Highway 1, this is your velocity. You know this already, okay? So to calculate velocity, you're going to use the following formula. Our velocity equals our change in distance over our change in time. The objective of this lab is to determine the relationship between velocity at the time of a collision and the distance an unrestrained passenger is thrown. Okay? So what do I mean by an unrestrained passenger? Think about you in real life. What should that be? Right, it should be as if you're not wearing a seatbelt in the car. So that's what we're trying to do. We're trying to equate how fast you're going with what happens if you're not wearing a seatbelt. Okay, hypothesis, your turn. Make a prediction about the objective. So, the greater the velocity, what's going to happen to your passenger? Make sure it's measurable, okay, and write it down now. I'll give you a minute. Next up, you're going to write down your materials, okay? And because everyone's doing this at their house, this means that everyone is going to have a different set of materials, and that's totally fine. But I want to show you what I'm going to use, okay? One, I have a measuring tape, okay? So I have one measuring tape. You are going to need some sort of a ruler, okay? I also have a small ruler like this that'll show me inches to centimeters because I really want to keep everything in centimeters, okay? So I also have 1 centimeter inch ruler, okay? That's just for me. I also am going to use my cell phone as a timer. So 1 cell phone timer. Okay, I'm going to show you the other things I'm going to use. I'm going to use a math textbook and a stack of loose leaf, 1 Hot Wheels car, 3 Hot Wheels tracks, a board, some tape, and my unrestrained passenger, which has just flown somewhere. But I will find it. It's a little bird. Okay. So write down all the things that you will use, right? So 3 Hot Wheels tracks, etc. Okay? So when you're like, but what do I use for materials? Let me help you out. Page 2, procedure. This is how to complete this at home. Okay? First, find something you can use as a ramp, something that is flat and straight. A piece of 2x4, a Hot Wheels track, sturdy cardboard. As long as it's between or larger than ½ meter long, that will be great. If it's longer, that works, but if it's shorter than ½ meter, that does not work very well. Okay? Step 2, find something that can go at the bottom of your ramp that has a flat surface and stops your ramp from moving any further. It should provide a bit of a flat surface for your car to hit. So I've used a textbook, and I've also used a brick in the past, or a piece of 2x4, or puzzles, or whatever, okay? Step 3, find something you can use as a car that can drive down your track. So I have a few Hot Wheels, cars at home. I happen to have this little emergency truck. That's what I'm going to use. You could also take 2 pieces of Lego that have wheels and make that into a bed. I'm sure you can find something around your house that you can use as a car. Okay. Next, look for something that you can use as your passenger. This person needs to sit on top of your car, so it can be bigger than your car. So it shouldn't be bigger than your car. You can use a piece of eraser. That's typically what we use in class. We can use a tiny bit of Lego. Maybe you have a Lego person or Play-Doh that you can make into a person. Keep in mind, it's supposed to act like a person flying through the windshield. So watch how big and the mass of that, okay? I'm gonna use this little birdie, and when he sits on top of the car, it works out okay. Okay, but in class we use cut out pieces of eraser. Next, position your ramp on an available stretch of floor. Rest one end on a chair and place the obstruction, so in my case I'm using the textbook, at the protruding end of the track. Okay, feel free to pause at any time. Okay, so what do I mean by this? I have my ramp resting on the chair, and at the bottom end I have the track. Okay, now could I have done this without the track and just used the board? Yeah, totally fine. I just happened to remember that Mason had some Hot Wheels stuff. Okay. Okay, get your phone ready with your timer because you are going to time this. If you have someone who can help you time, that's great. If not, this is doable on your own, but practice a few times first before you start keeping track of your data. And here's what you're going to do. You must let go of the car from the same point on the track each time. Prop up the other end of the ramp at a desired height. Okay, so right now it's resting on a chair. Measure the length of the ramp that the car drives. Measure the distance from the floor to where you will let the car go from, and record the height of the ramp in all three tables. So I'm going to do this with you to show you how I did it. Okay. Okay. So I'm going to get my measuring tape. Good. So I put my measuring tape down, and my track is going to go down this my car is going to go down the whole track. And so when I started from the back, it is at 33 inches. Okay, so it drives 33 inches, and the height is, so I'm going from the floor to where the car is 12 inches off the floor, 1 foot. Okay, so where do I write that information? Here. Length of the track. Okay, so right now I'm going to write 33 inches, and I'll convert that to centimeters after. Okay. Description of the height, I put off the chair. Height of the ramp, so I measured that to be 12 inches off the floor. Sorry, my husband is trying to get pop and chips behind me while being very quiet. Okay, so that's how high the ramp is, or how high that car is off the ground. Okay, next we're going to try some trials. Okay, here we go. Okay, so it says place your passenger on the top of the hood of the toy car. Okay. Timer. Okay. Okay, so I have my timer, my stopwatch. Step 7, place the passenger on top of my car. Okay, so I tested out this little birdie, I tested out an eraser, I tested out different things at the bottom of my textbook, all to make sure I had something that when the car hits the textbook, the passenger is going to fly, but the car stays there. Okay, so it'll take a little bit of time of trial and error. Okay, so I'm going to let my car go from the top of my track here. and my birdie flies, okay, or my passenger flies, okay? So I want to make sure I put my bird or your passenger on your car in the same spot all the time, okay? And also always let it go from the ramp at the same time, okay? So now I'll do that, but I'll time it. Okay, here we go, ready? So trial number 1, I have my birdie on my car. Stopwatch ready, 3, 2, 1, go. Okay, and as soon as it stops or it hits the track, I have my time, okay? So, time 0.69 seconds. That was my first one, okay? At the same time that I do that, I also need to measure how far my birdie flew, okay? So I'm going to take my measuring tape and you measure right from where the car hit your textbook in a straight line, okay? So I have 16 inches, okay? Okay, so now I go to my next table, data B, height of my ramp, it was 12 inches. And how far did it fly? 16 inches. Okay, so now I'm going to do that again. So that was my first trial. Now I'm going to do my second trial. Okay, so I take my person, my passenger, take my car, I have my stopwatch again, I clear it. Okay, 3, 2, 1, go. Okay, so this time I have a different time, and clearly the passenger went a lot further. Okay. Okay, so for my second trial, I have 0.73 seconds. And how far did my passenger go? Well, he's way over there. So, can you see that? Okay. It doesn't matter if he ends up in a curve or he flies in a curve, just go straight in a straight line. Okay. So here's the car to the bird. I have 45 inches. Okay, so for my second trial, 45 inches. Okay, and then you're going to do a third trial. Okay, so this is important why you want to do more than one trial, because if we relied on 16 inches, clearly that's not fair, nor is 45 inches. So hopefully the third one will have something in between or something closer to one or the other. Okay, so once we've done that, you have then done step 8 and step 9. So you'll do 3 trials. I'm looking here at number 10. You'll do 3 trials for this height, record the times in data table A, and at the same time record the heights. Okay? You have to do them at the same time. When measuring the distance, the person is thrown. Start from the point of collision, from where the car hit the outside force to where the passenger finally stopped moving in a straight line. Okay, like I showed you. Then you're going to find the average time it took the car to reach the bottom of the ramp. So add up all your 3 times and divide it by 3, and an average distance the person was thrown by adding them all up and dividing by 3. Okay, so over here, well, I guess I should just do it. Just a second here. So very quickly. Okay. 3, 2, 1. So I have 0.71 seconds and 53 inches. Okay, so then I'm going to find the average for this and put it here, and the average for this, and I'm going to put it here. Okay, so I'm going to have a value, we'll call it A, and value B. Okay. Okay. We measured the length of the track already. We did number 13. Now you're going to calculate the velocity of the car. So using the formula from the beginning of the lab, which is velocity equals the change in distance over the change in time, record your velocity in data table C and complete that table. Okay, so the next page looks like this. Okay, so here I even given you little hints at the top. It says use the same distance for the whole column. So the distance your car traveled on the ramp, so for mine was 33 inches. Okay, and I'm going to change that to centimeters, but I'm using this value right here. Okay, and the average time to drive the length of the track, so the average time would be this one. Okay, so I'm going to have my value for A here, and then I'm going to calculate velocity, right? So velocity is going to equal my distance, my change in distance over my time, which is A. Okay, so I'm just showing you this so you know where the values go, and then you'll do that for the rest of them as well. And then you'll complete your lab report. It's actually pretty neat once you start going and once you see the results. It's pretty cool. Thanks for trying. I can't wait to see your experiments. Feel free to send me a short, not this long, a short 20-second, 30-second video of one of your trials.